In order to graph a piecewise function, what we need to do is focus in detail on each piece and back out and focus on the big picture. So I'm going to start with the first piece of this function, which it's going to be really helpful for me to write that as y equals -3. Each of these is y equals because the whole thing is f of x equals. Once I have this written in the form y equals, I can see what kind of function that is and what the graph should look like. This is a constant function, and therefore its graph is a horizontal line. What I'm going to do is draw this line very, very lightly. I'm not going to include all of it, but sometimes it's helpful not to try to think about everything at once. So let's get the line established and then start to worry about the pieces that we're keeping. So here's my line, and the numbers that I am interested in are from x equals -4 to x equals -1. So I really just want to keep the part of that line that's between those numbers. So that means I don't want any of this part that's outside of those. I'm going to now darken this part that I want to keep. Actually, I'm going to thicken it too, because sometimes when you're right over those grid lines, it doesn't stand out all that much. All right, so I'm going to do this process for each piece in my piecewise function. Then at the very end, I'm going to look at whether they meet up or not. Looking at the next piece, I have y, of course that's not what I meant to do, y equals x minus 2. And let's use a darker color for this part real quick. And I'll switch to that lighter color when I go to draw the line. This is a linear function. It has slope 1, so I would think of that as a positive 1 over 1. And it has y-intercept -2, so I would want to start thinking about the point 0, -2. Even if x equals 0 isn't in my set of x values, I'm going to go ahead and let myself use the y-intercept to draw the line because it's just easier. We're so used to using slope and y-intercept. So there's my y-intercept. I'm going to try and pass through that with a slope of 1. That looks right. So there's my line. Now I want to think about the numbers that it's between. I only want the part that's between -1, this same -1, and +2, which means I don't want any of the part that goes outside of these. And I do want to darken the part that I'm keeping, which is in between them. Now I'm going to look at the last one. Let's go ahead and use red for this one. And I'm going to write that as y equals, same thing again, y equals 0.5x. This is going to be a little bit easier for me to work with if I think of that as a 1/2. Decimals are okay, but when it comes to slopes, fractions are usually better because they give us a rise and a run that we can use. And for the y-intercept, this doesn't really have an added term, right? We want to think of that as being +0. It's equivalent to that equation with a +0. So that tells me that my y-intercept is 0, and therefore this line passes through the origin. Now I'm going to use a very, very light kind of, this color is called cantaloupe, to draw this line starting at the origin with a slope of positive 1/2. And again, identifying those numbers, we want 2 as one of the boundaries and 4 as the other. So I'm going to cross out the parts of this that I don't want. And then I'm going to, whoops, I crossed out a little too much. Darn, and we were doing so well. Let's see how many of those I can get to take out. Oh, good. I was able to remove them all. Right, everything to the left of 2 I'm taking out. But that piece between 2 and 4 I'm keeping. So now with a nice heavy red brush, I will go ahead and highlight that part. I'm going to come through and erase little bits of this. This eraser will also erase the grid if I let it, so I'm not going to go too heavy with it. But just to make it look a little better, right? There's a lot of noise here. And I recommend doing the same with a pencil. Doing this early stuff with a pencil so that you've got something to erase. Now I'm going to come through with black. A nice black with a stroke of 3 and figure out my endpoints. So first of all, this endpoint is included. Right here they meet, so it doesn't matter. It doesn't matter which function applies, they both give the same output, so I just go ahead and darken it. And when I get here to x equals 2, that's where I have to really start thinking about it. The middle graph has an inclusive inequality at 2. The third graph has a strict inequality at 2. That means that the middle graph wins and the third graph loses, right? We put an open circle here. I only have to think about that where the ends don't meet up. If the ends meet up, it just doesn't matter, right? It's a solid point and it just doesn't matter which function it came from. If the ends don't meet up and you have a discontinuity, that's when you have to figure out solid or open. That's why I waited until the end. There's no point going through that exercise if all of the endpoints are going to match up and you don't end up really caring which one is included and which one is not. So for the very end, we answer, is this function continuous on its domain? It was continuous here at the first possible point where it could have broken apart, but if it has any breaks at all, it has a discontinuity right here, we have to answer no.